Hello, welcome back. So today I'm going to be doing another review of one of the watches. So this is one of my vintage Soviet watches called the Slava Medical. Not sure what Slava means, but I think given the new recent slogan Slava Ukraine, I'm guessing this is meant glory, the brand. So Slava Medical, it's a watch that I've wanted for a while. It's because I wanted a watch made. I was searching for a watch made in my birth year, 1986. But as you do some research looking into vintage watches made in the 80s, most of the watches company at the time were actually making quartz watches. So if you looked around, you realize, okay, the Russians in the 80s, they were still making mechanical watches. They were doing the old school way still in the 80s. I mean, they had quartz watches, but the mechanical watch didn't die off in the 80s. So I learned about this watch actually from a watch podcast I was listening to called The Two Broke Watch Snobs. And one of them were chasing after this watch for a while, and it kind of got me investigating a little bit about this. So this is a Russian doctor's watch. So you can tell by the logo here. I think this is called the Rod of Asclepius. Anyway, so I found this watch and I realized it was a pretty unique shape. It's not round. I think back then they called this a fridge case. Not sure. I can kind of see like a vintage fridge in the Soviets. Probably had this rectangular shape. I think nowadays if you had to classify the shape, I'd probably call this maybe a Apple Watch case. Anyways, so I also work in the healthcare industry, so this watch really piqued my interest. So I started looking and I found one in very, very mint condition, almost new old stock condition. And it came in this box, so I'll show you what this is first. So yeah, this is the box it came in. Has that Rod of Asclepius on it. I think this is Slava in Cyrillic, and here it says made in the USSR in Cyrillic. It's a pretty simple box. You just open it. Came in its original packaging. I don't think there's anything else, just a cushion. So I'll talk about these after, because I did put a see-through case back on it. This is the original metal case back. So the original paper from back then. I mean, it's all in Cyrillic, can't really read much. But yeah, that's the model number 2482-261405. I think commonly people just called it the Slava Medical or Slava 2482. These are the temperature testing ranges, I guess. This is the serial number. And it's made in April 1989. Yeah, it's a pretty simple piece of paper. Came on this tag. Yeah. So let me just put this back. The case of the watch is made out of chrome-plated brass because it was cheaper that way. But this piece, the case back, is actually the only piece that's stainless steel. And that's the serial number matching the paper. I think this is actually a very low serial number. If you look online, most of the serial number are like 10,000 or something in the thousands. This is a very low number, and I think the later generation ones, they actually put a more design engraving at the back with the CCCP. But these earlier serial number didn't have that. Yeah. Let me put this back. All right. So where were we? Okay, so like I said, I was looking for a watch in '86, and as you do, some research, I think many of us know that in '86 in the USSR there was also a big incident, Chernobyl, and there were some stories saying that because of the radioactivity, a lot of the electronics that the people helping out were breaking down. And there was some people saying that, quartz watches also were not functioning as accurately or even just dying on them. So a lot of the idea in that period was trying to go more mechanical. And so this watch on that serial paper said was made in '89. All the serial papers I have looked online all said '89. So I'm assuming this watch probably was made in '89, given how low that serial number is, and it was still '89. So yeah, so they went with the mechanical movement, which was perfect for me. And let me just take this watch off. So I put a see-through case back on this. Normally I don't wear this watch with the see-through case back because it's not as tight. Like, this isn't designed for this watch, but for this review, I guess this would be easier to talk about this. If you're wondering and interested in getting a see-through case back, this is the thing I ordered. Yeah, you're gonna have to just type that into Google. Like, I think this is the measurements of the outer rim, inner rim. Yeah, it was pretty cheap. Okay, so the dimension for this watch, let's do the measurement. I believe the diameter was 36.5. Yeah, 36.5-ish. Lug to lug was 44.5. The thickness is 11. And doing calculation of the surface area, this watch wears almost like a third, 43. Lug width is 18. It's acrylic glass. Like I said, it's chrome plated brass, but the case back was stainless steel. And this is a pulsometer watch. So what is a pulsometer watch, you ask? It's basically a tool for doctors to measure a patient's pulse rate. Sorry. Yeah, so there's two kind of graduated timing thing, and you'll be able to measure the pulse rate by kind of just counting from either here or here. Let me try to show how this works. By the way, I think this was the only mechanical pulsometer made by the USSR. I think, I'm not sure. I'm guessing it's maybe due to the Chernobyl issue. Okay, so this is how it wears on my 7.5-inch wrist. So what you would do is, actually, I forgot to wind it. Okay, let me just wind it a little bit just to show it off. So what you would do is, if you were the doctor or the medic, you would take the patient's wrist, hold it on one of your hand, and feel for their pulse. Once you feel it, let's just say this is the hand, you would have to wait for the second hand to either hit the 12-hour mark or the 6-hour mark, and then you would start counting 15 pulses. Yeah, it says 15 pulses there. Alright, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Alright, so my pulse is at about 100 because I'm filming a YouTube video. So yeah, that's how you count 15, see where the second hand is at the 15th pulse, and it'll tell you what their heart rate is. All right, so let's see. So the dial had this cool inner sunken region. There are texts written in both Cyrillic and Latin. 26 joules. Here it says made in the USSR in Cyrillic, so CCP. Yeah, it has this cool Lollipop hand to kind of guide you in reading the second hand easier. There is also another variant of this called the KFG variant. Not many people really know what it is. Some people say it's like a Chinese clone, but then I think recently people found out that there is a famous medical school back in the USSR called, something Russian, but it would stand for KFG. So I think that's probably the reason for that variant. So yeah. Let's talk about this movement. Let me just get this out of the way. Alright, so this movement is called the Slava 2428. Some of the interesting aspects, there's a few interesting aspects of this watch. First thing is that the date assembly is actually part of the mounting frame for this watch, and you would do the quick change of the date with the side pusher. And you would do this, yeah, and it will change. The date change is instant, but the day change is not. It takes about roughly an hour to change over. So, all right. So yeah, the day change should be instant, but the day would not be. So this is 9, and then so about almost 10:30, it will start kind of engaging, and by the time it gets to 12, then everything changes over. Sunday was colored in red, and every other day would be colored in black. All right. So yeah, this watch was made in '89, and when I got this watch, I gave it to my friend that worked in the nuclear power plant. And according to him, this watch does have higher than average levels of radiation, only by a small amount. So I assume this watch was worn by some healthcare profession that was helping out with the Chernobyl incident. All right, so let's get back to this movement. So another interesting thing about this movement is how big this balance wheel is. It does run at a very low frequency, 2.5 hertz. And some of the reasoning behind this is the slower the beat rate, the bigger the balance wheel they can make it. And with the bigger balance wheel, it allows this watch to be more rugged because it has a bigger inertia force going around, and little bumps and stuff around daily use wouldn't throw off the accuracy as much. There's arguments with whether a high beat is better for accuracy or a low beat. If you look at like really high-end watches, most of their movements are made in a lower frequency. But high beat is for sure more accurate. But the issue is that higher beat rate, it produces the increased speed and pressure and the sliding friction at the escapement and pallet. So it's just more wear and tear. Like, if you have a sports car and if you drive it at its max all the time, then it's gonna break down much faster than compared to if you just drive it regularly. So I think the high-end watches, the reason is because it's easier for them to make, a bigger balance wheel. It's more pretty, they can do more decoration, and they also use other methods to increase its accuracy rather than relying on high beat rate. Which leads me to another aspect of this watch that's very interesting. You see these two thing here? These are so this watch has 2 barrels, 1 and 2, and they're pretty small barrels. So the power reserve isn't like crazy. I think it's 42 hours, 38 or 42 hours. But these 2 barrels are actually arranged in parallel. So they wind and discharge at the same time. Modern dual barrel, a lot of them are made in serial. So one will discharge and then it will kick in to the other one. So this will give you a very long power reserve. But dual barrel and parallels are a little bit more rare. Again, it's actually found more in high-end watches. So this movement, it's like taking all these ideas from high horology, and that's making it into like a utilitarian style. The finishing is just almost none. It's just what it is. So parallel dual barrel, the idea is to deliver the torque more evenly throughout the gear train, because instead of having one very large barrel pushing out a lot of torque, they divide it into two barrels to push it out more evenly, which I'm gonna get into a little bit of discussion about constant force. All right, let me just put this back on this. All right, so constant force. I learned about this through watching the YouTube channel Watch Our Sci. It's a great channel. It's very informative, and it's considered to be like the holy grail of watchmaking. And it's debated if it's even like considered a complication, because it doesn't really add any function, but its function is to make timekeeping more accurate, sort of like a tourbillon. So if it is considered a complication, then constant force complications are some of the most expensive ones you can find, like remontoire, resonance, Fusi and chain, all that stuff. So the idea is to try to solve the issue of how the mainspring torque changes during its delivery of power. So if the analogy everyone uses is if you had one of those toy spring cars, if you wind it all the way and you let go, the initial velocity is very fast, force is very fast, and then it kind of slows down as it unwinds. So the spring torque, if you look on a graph, it's kind of like a little hill. So it starts off very, very strong, and then it kind of goes into a pretty linear decrease, and then it tapers off much more significantly at the end. So the idea is to keep this decrease more constant, rather have these significant changes. And there are many ways people do this. You can do this at the barrel level, you can do this at the escapement level, so many different aspects, but basically it's what watchmaking kind of chases after. And this whole concept of constant force got me into appreciating mechanical watches even more, and it showed me the kind of the philosophy behind high-end watches. So, as many people kind of know, quartz watches kind of made accuracy, like everyone could do quartz accuracy easily. It kind of killed off the mechanical ingenuity, because it's just, in a different sphere. So many people, when they look at quartz watches and the ability how it can be so accurate, you almost kind of think that it's sort of cheating, because it's so good at what it's doing that it makes mechanical watch, all these small little innovation, kind of pointless. So we kind of put quartz watches to the side and kind of stay our own little hobby with mechanical watches. But the interesting thing is, if you look at really high-end watches, most of them are like hand-wound movements, not automatics. A lot of the arguments is because they want to not have a rotor to able to show off their finishing and all that, which is all true. But the other main thing is that in the realm of like high-end watches, automatic is actually kind of considered cheating as well, because automatic is actually a constant force complication as well. You know, it's able to keep the barrel wound at a kind of smaller range, so that the barrel doesn't kind of decrease its tension over the day of wear, because it's also constantly being wound up. And I think that's also one of the reasons why high-end watches, they don't have automatics, because all their ingenuity in making a remontoire or Fujian chain is just pointless if you have an automatic rotor constantly winding up the barrels. So let me just talk about a little bit about different constant force complications, I guess. So at the barrel level, the earliest aspect of a constant force is called a Fujian chain. Fujian chain is basically having the barrel unwinding to a different barrel, but it's more like a bicycle wheel chain. So initially the diameter would be small, and it gets bigger and bigger and bigger, so it kind of even out the torque distribution. As the chain diameter gets bigger and bigger, the torque also kind of balances it out. I'll put a picture in there. Then there's also other aspects called the Maltese cross stopworks or equal force barrels. They basically, when you wind the watch, it doesn't allow you to wind all the way up to 100%. It'll stop around like 80%. And as it discharges, it also doesn't allow it to discharge below 20%. So this way, they basically use the most stable part of the chain, part of the spring, to stop this change in forces. There are other innovations called the tensor mainspring, and then there's the double barrel parallel configuration. Like I said, automatic is also considered one. You can also say like new lubricant, new spring material could be considered a different aspect. And so that's all the innovations at the barrel level or at the mainspring level. Innovations along the gear train is a little bit more tricky. Some company has used special teeth, like H. Moser has their own gear teeth innovation. Agenor has its own gear teeth as well. It's called gear without play. So these, I'll add in pictures. They are basically innovations in not letting a small little force to be lost during the gear train. FP Journal also has the resonance watch, which is based on the resonance theory, where you have two barrels with its own two gear trains going down to one escape wheel. So the small changes in forces will kind of be neglected or compensated by the other gear train through resonance theory. And then at the escapement level, there are constant force complications like the remontoire, which kind of at the escapement has a different wheel that kind of winds up a specific amount of force in order to let it out to the escapement. So it's always constant. If you do that once a second, then you can kind of have a deadbeat second movement. believe Breguet also has something called the natural escapement or central impulse escapement, which is also a different way of balance out the forces. Girard-Perregaux has their own constant force escapement. You can also like argue the George Daniel coaxial or omega coaxial, and the new Grand Seiko escapements are also a type of innovation in constant force escapement. And there are some more unique ones like the mosquito escapement, the desmodromic escapement, the hairspring in the actual balance wheel. I think H. Moser also has made innovations there where they put a double hairspring. So one spring spinning one way and then another spring on top spinning the other way. So it kind of evens out the pivot. It allows the pivot point to stay true middle instead of kind of forcing it slowly to one side. And yeah, other aspects, tourbillon, you can kind of argue that's a constant force against gravity. And balance wheel material for temperature compensation, balance spring material like silicon escapements. They're all aspects to improve the constant force. So yeah, all that is quite a interesting, rabbit hole to get into when you really get into mechanical watches. And this is a pretty cheap way to kind of get in on some of these innovations with the big balance wheel, dual parallel barrels, and it's just a cool watch, So yeah, this is going to be the review. I'm going to see if I missed anything. I'll add in the description maybe. And I'll see you guys next time. Thanks.